Guys, our last topic for our hydrosphere unit is weathering. And so we'll be wrapping up with this today. And next week, we'll be doing a little bit of assessment activity, but it'll all be open note. So it should be pretty low stress for you. Weathering gives rise to some of the most beautiful and interesting things we can observe on our planet. So I'm really excited to talk about it today. Weathering is just a process that breaks down or changes rocks into smaller pieces. So there's a lot of different ways that this happens, and that's what we're going to talk about today. Water is probably the most common and most important one, and it gives rise to a lot of really interesting formations. So there's two types of weathering. There's physical or mechanical weathering, and that is the physical act of rock particles being removed from a rock. And then there's chemical weathering, which is of course my favorite because it involves chemistry. And that's when something interacts with the rock to cause a chemical reaction and change the shape of the rock. And so I think that is really cool. And as you can see in the lower right, that gray rock with those interesting craters is the result of chemical weathering, which is pretty cool. We'll talk about physical weathering first. Physical weathering is the most common, and it occurs when rocks and other landforms are broken down by physical factors. This type of weathering does not change the chemical composition of the rock or the minerals. It just crushes them into tiny pieces. But if you had sandstone before, you still have sandstone. You just have tiny sandstone. So take a minute in your student response sheet and think about two examples of physical factors that could maybe change the shape of a rock. So go ahead and write those down. So the physical factors that change rock include wind, water, sun, ice, and temperature change. And all of these happen on a very regular basis all around us. Erosion is the action of rock, soil, or other dissolved materials being transported from one location to another. So a lot of times physical weathering happens, and then after the physical weathering, erosion occurs. So something comes and it breaks down the rock, whether that's wind or water or ice. And then once the rock is broken down, the wind or the water can carry the rock away to a new location because it's so little. So those two things kind of work hand in hand, weathering and erosion. I want you guys to take some time on your student response sheet to predict what kind of physical weathering caused each of these changes. This is through slide 10. So go ahead and pause, look at your sheet, look at the pictures, and go ahead and work through these to think about what physical weathering caused the change and what type of evidence suggests that. Okay, so for this first one, this is definitely physical weathering caused by water. And the evidence that we have to support that is the fact that these little interesting rock formations are literally in the middle of the ocean. And you can see some of the lines on the rock show the depth of the water at different points, which is another indicator that the ocean water was weathering and then eroding the rock away. This one is beautiful, and this is a canyon. And so this is also water that's causing this weathering, and it's additionally causing erosion as well. And over time, this river has just worn away the rock and created this beautiful canyon. So this is a very famous rock formation in the American West, and it is in Arches National Park because there's a lot of these really cool formations out there. And this was caused by wind. And the thing that can suggest that to us is that there's no water around, and it's really at a high elevation. You can see kind of based on the mountains and the other hills that give perspective. And so it doesn't seem likely that water has caused this weathering. And so the wind in this area has caused basically sandblasting, which has allowed for this unique formation to occur. Okay, this little rock is a lot less glorious and dramatic than the ones we've been looking at, but you can see it's split really cleanly in two right here. And the snow that's surrounding it and the sunlight suggests to me that we probably had ice wedging. So there was some water melting and freezing and melting and freezing and splitting this rock. It also experiences temperature extremes, which could contribute to splitting. And, the sun might be contributing to that a little bit as well. Lastly, we have this beautiful river scene, and we see a lot of really lovely, smooth looking stones. And so those are experiencing physical weathering from the water in that stream or that river. And the evidence for that is the river. Yep. Is that a tiny person? What do you think? I can't tell what that is. Okay, anyway, moving on. Physical weathering changes the surface of the earth really dramatically. It causes these beautiful landforms, and it does that through the erosion caused by water, ice, wind, sun, and temperature change. We have beautiful canyons. There's U-shaped valleys that are typical in especially mountainous regions that are caused by weathering and erosion by ice, specifically glaciers. We have sandstone arches, which are wind, the sea arches and sea stacks, which are weathering and erosion by water. There's deltas from water, from rivers, moraines and glacial lakes, like what's pictured to the right. And then of course caves and sinkholes, which are weathering and erosion that's happened underground. Chemical weathering occurs when there are changes in the chemical composition of a rock or a mineral based on its exposure to the environment. So this can be a lot more dramatic, and I think it's really interesting from a chemistry standpoint. So think about what are two examples that might chemically change a rock, and write those in your student response sheet. So there's kind of two things that can happen with chemical weathering. There's a decomposition change that can occur, or there's like a dissolving or breaking down of parts of the rock. These changes are usually the result of other minerals or chemicals interacting with the rocks, often from rain or as gases. So water is the number one source of chemical weathering. Oxygen also contributes a lot. So if you've ever seen like sandstone, right, is that beautiful red rusty color, and that's from oxygen interacting with the iron in the rock, and it's changing the composition of the rock. Living organisms, particularly lichen and other plants, can alter the chemical composition of rocks, and of course acids, like acid rain, can change the chemical composition as well. So water can dissolve minerals in rocks, which causes softening or dripping, and this is called hydrolysis. And this is something that can cause significant problems in different parts of the world, because sinkholes develop and stuff like that. Oxygen can react with rocks to create changes in chemical composition, such as rust, and that's oxidation. So that's what I was talking about before with sandstone. Living organisms perform chemical reactions to get minerals from soil and rocks. So there's certain chemical minerals that living things need in order to survive. And so living organisms will use chemical reactions to extract those from the ground. And a good example of this is lichen. Lichen can dissolve dissolve rocks, because its roots expand into the rocks and split them apart, and then they take some of the nutrients and the minerals out of the rock, changing its composition. The last one that's really important is acids. And so sometimes water reacts with things in the atmosphere, and that creates acids. And this can cause rocks to dissolve when those acids fall as precipitation and interact with rocks, which is pretty concerning in a lot of ways. It's also really bad for trees and other stuff because acids are, kind of potent. So I do want you guys to learn a little bit about how rain becomes acidified. So you have a link to this video in your student response sheet, and I want you to go ahead and answer questions 1 through 6. And then there's a second video because there's kind of 2 types of acid that's occur in acid rain, and so we want to really cover both of those. So you have a second video, another 6 questions. So please watch both of those and answer the questions. All right, so now we want to look at our chemical weathering and what causes the different changes. So you can make your predictions in your student response sheet, and then come back to this video and we'll talk about them. So in this chemical change, we see some beautiful rust colors on this rock, and so that suggests to me that this is oxidation. So this is oxygen causing this chemical change. This cave, you can see that there's water, and you can also see that things are dripping from the ceiling and forming piles on the floor. And so this is definitely hydrolysis, chemical weathering. This little stuff is called lichen, and lichen can cause the chemical changes in the rock as it takes out the nutrients. And then this one with these interesting cavities is definitely water and potentially an acid causing these changes. So that's about all there is to know about weathering, at least for the scope of this class. And that concludes our study of the hydrosphere. So next Monday, I will be reaching out to you guys with some details about how we are going to assess your knowledge of the hydrosphere. And we will be taking all of next week just to do a really nice job on that, so that we can feel confident moving forward into our study of the geosphere, which is going to be super fun. It's my favorite unit. Okay. Have a good weekend, you guys. Love you.